Okay, welcome everyone in the room and everyone online to our panel discussion today about what the heck NSF means by convergence. We have here a great group of folks. We have Rajiv Ramnath and Elena Irwin. My name is Maureen Langlois. We'll also hear from my colleague Kate Hayes-Ozello. Online, we have a panelist, Sathya Gopalakrishnan, and I will introduce all of our panelists more thoroughly in a few minutes. For online participants, I think we are probably going to keep everyone muted except Sathya. And if you have any questions, please feel free at any point to put them in the chat dialogue, and then we will be able to field them later when the panel discussion begins. Can you make my PowerPoint happen here?
If I do, I lose her audio. I can
do
that, but there's a conflict between the two inputs. So would you like to do that first and then?
That'd be perfect. Okay. Thank you.
A second. Bring that back up.
Okay, so what we're going to do is I'm just going to do a quick level setting on even the words we're using. And although the question of what convergence means is kind of what we're talking about, but the kind of what brought us here today, and then my colleague Kate Hayes-Ozello, also from the Research Development Office, will kind of do a little rundown on some of the people that won an award last year, and then we'll get on with the panel discussion. Not yet. Okay, so launching into this, I prepared a brief history of convergence talk. Right. In the beginning, there was a lot of talk about interdisciplinary, transdisciplinary, multidisciplinary, team science. All of these words have been thrown around. In the early aughts, some conversation began to precipitate about some of the convergences, some of the ways that some disciplines were coming together. And those were some examples in especially the biomedical fields, such as biochemistry, and then with the Human Genome Project. So there were mentions of the word convergence back in the 2003 to 2010 in the literature. This is all a crib, by the way, from the latest National Academies report where they did a really nice history of convergence. So as you'll see online, perhaps in my fabulous PowerPoint slide, which can they see online? There's President Obama. If you were not in the room, you could see that President Obama is on the screen. I'll just do it in performance art. President Obama is on the screen talking to the National Academies in 2009, where he says the historic convergence between life sciences and physical sciences that's underway today is a very good thing, et cetera, et cetera. He was in favor of that, and the NRC issued a new biology for the 21st century that same year, 2009. So a new biology. So all of this conversation often kind of started in that sector of things, biology. MIT really ran with this with a white paper called The Third Revolution, a convergence of life sciences, physical sciences, and engineering. So look, we started at life, now we're going physical to engineering. To them, the third revolution meant first it started with, what did they call it? Oh, molecular biology. The second revolution was genomics, and the third revolution is the convergence revolution. But in their mind, it was life sciences, physical sciences, and engineering. In 2014, the National Academies did their first report that was entitled Convergence, where they expanded now beyond that, right? So they've now got life sciences, physical sciences, engineering, and they have a fourth one called And Beyond. Although it's funny, they kind of start talking about social sciences there. Ish. You're the and beyond part, Ish. Elena and Sathya.
Ish.
Okay. Then in 2016, NSF tried to operationalize this idea by announcing their 10 big ideas for future NSF funding, and they institutionalized a program called Growing Convergence Research to make to grow convergence research. The one that the audience who's online can see, I will do performance art for that one too. There's grain and a report. Reflects that many institutions have taken up this idea, including the Association of Public and Land Grant Universities had a whole big initiative. Apparently, maybe Ohio State is having a whole big initiative this year. So it's become quite popular. So note, I have deftly talked about its history without actually defining it. So Doug, can you advance, please? Okay, so to get to where we're trying to have our discussion rest today is, what does NSF mean by convergence? They have two primary characteristics. One is research driven by a specific and compelling problem. So it's driven by a problem. Often problems are owned by people who deal with them every day. We could call them stakeholders or users. And then deep integration across the disciplines right from the beginning of the process. They have several exemplars on their website, which I noticed throughout the last year have changed, again, from being more in the biological engineering realm, for instance, synthetic biology, nanotechnology, to now being in the cyber-physical systems realm with a multitude of applications, energy systems, agricultural systems, health systems, many examples. So, can you advance one more time, please, Doug? Okay, so last year, NSF created a new program called Growing Convergence Research, and that one is it's a kind of an incubation program that I'd love to hear Sathya talk a little bit more about. But this is going to be an annual funding opportunity to invite teams that have ideas that fit nowhere else in the NSF world to apply for funding of up to $3.6 million over 5 years. The next deadline is in February, which is why we wanted to have this conversation, and part 2 of this conversation, which will be a live facilitated networking event.
No more performance art.
Darn it. But you missed the beautiful. No, it's okay. That will be coming up in a few weeks, which I will tell you about again in a little bit. So this convergence research opportunity is just one hook that our faculty may be interested in here at Ohio State. So we wanted to kind of get it on people's radar, and also, you know, to flag that it's an annual opportunity for the next, you know, at least, let's say 5 years, I'm just gonna guess. Although I have a former program officer in the room who would say, we never know for sure, right?
Right.
Okay, cool. So to get to that, we wanted to hear from some panelists today, which we will do, on what NSF might be thinking with this type of call. But of course, you can understand that there are lots of calls out there now where convergence features as a critical element of trying to solve a problem using multiple disciplines. So to tee up my colleague Kate, we wanted to look at who won this year, which was the first round of Growing Convergence Research proposals. So the proposals came in May. They were reviewed at NSF. One of the reviewers is actually Sathya, who's online, so we'll hear from her. And then some awards were just announced pretty recently. So Kate, actually, my colleague, who you'll hear from in a moment, actually called up a bunch of the winners and said, how'd that work for you? What was your idea? How did it start? Kind of what are your takeaways? So Kate, you want to come on up? Do you want to be here? Yeah. Great.
So I'm
Can you advance that, please?
trading places with my friend and colleague Maureen. We're going to talk a little bit about the winners. So I called, there were 13 teams, if you don't mind going ahead, yeah. There were 13 teams awarded from the May 1, or the May competition, and of those, about half of them were multi-institutional. The projects were awarded in pretty broad areas: sustainability, data plus, and rules of life. As Maureen just let you know, we reached out to the award winners to say, hey, can you give us some insights? You know, what made you particularly competitive in this round? So if you would go ahead, please, for me. These are the actual titles of the projects, and what I'm going to do is pull out 2 examples from these projects to talk to you a little bit more about. The first example, please, is based on the West Coast, and the disciplines involved here are listed, as you can see on the slide. The team, in this case, was pretty much run by the PI. She was aware of others in the community of toxicology and chemistry. What she thought was really transformative for her was this nucleating event. So in this case, it was a regional meeting where she met with some of her colleagues. She kind of had a project idea, and she talked it up, and they said, yeah, you know, this sounds like a great idea. This group had not worked together before, so there was no obvious collaborative track history, but they knew each other. And the PI in this case led the team. She picked others that she thought would complement the skill sets that she needed for the project. They enlisted a couple of partners initially. You can see a federal group, the NOAA, as well as a local or regional Marine Science Center. By the time they actually applied for the grant, they had more than 35 partners just through word of mouth and leveraging regional activities. Could you go ahead and advance? The thing about this project that were some of the special elements were that it was multi-scale. So we dealt with nanoparticles, microparticles, life cycle, all the way from the particles themselves up into changing policy and social attitudes. The project involves field work as well as lab work, and they encompass a very large geographical region. The other thing is that the project's really topical. It's very much in the news. Microparticle or microplastics pollution is a very big deal. And so the timing of this, of course, is also very important. What the PI emphasized to me was that she was aware of and utilized science of team science resources. She was the one that actually picked most of the investigators, and in this case, they were established investigators. The folks that she picked generally didn't have big egos, so egos weren't a big issue. And importantly, she had a translator, because when you have this many broad disciplines, often one of the biggest barriers is how to get people to talk to each other. So she had enough familiarity with the different disciplines that she was able to serve as a translator for the group and help establish some of the common terms. Can we go to the next one, please? In a different example, this project is based more on the East Coast with Penn State and NYU. These disciplines are in virology, material science, data science, very broad again, but the team composition is different. This is a young team, not necessarily well established. What they prioritized was getting together physically. They got together frequently. They wrote together. Nobody bore the lion's share of this project. The project idea itself was generated by the team. The PI in this case had enough broad background that he was able to serve as the translator for the group. And like I said, the team members already knew each other. In this case, they didn't have any external partners. I think NSF really liked their project and gave them an extra $100,000 to pull together an external advisory board and to potentially recruit partners as the project goes on during that first year. And as I said before, the project actually arose from a core idea that the group generated. Thanks. Yeah, go ahead. So, from the rest of the teams, those are just a couple of examples that show you the differences and the breadth of some of the project areas in these groups. Some of the message that came through to me as I talked to these different folks were that you have to have an overarching theme, obviously. Craft a vision early. And if you're the one generating the idea, you have to be able to sell it to your team. So it takes a strong PI to really lead this. Build your team carefully. Ideally, you can pull in people that can think outside of the box. If somebody's too firmly entrenched within their discipline, that they're not willing to give and take and share, it can make things very difficult for the team as a whole. Language barriers are by far the most difficult aspect of any kind of collaborative team science effort. And that was repeated to me multiple times through this. If you can find somebody that's a translator, that's really, really helpful. Getting together, learning to listen is another important thing. So holding on-site retreats at various time periods throughout the proposal development process can be really helpful. Include a critical mass of members. It's really obvious to reviewers if you've got a token member of a different discipline. If you've got different flavors of engineering and then somebody from social sciences, and their efforts aren't really incorporated, it shows. And so be sure that you've incorporated you've built your team carefully and that everybody's a part of the group. A basic understanding of the dynamics of team science can be really important and helpful. Yeah, one more time, thanks. Engage your partners and stakeholders early and often. Make sure that they're an integrated part of the team. If you can involve them in the proposal development process itself, do so. Consider a range of partners. Don't just necessarily think that you're restricted to other institutions of higher education or other colleges and departments. Go out, look at the community, look at museums, look at federal labs. Lots of other different kinds of partners can be really important to actually performing your project. I can't say enough about broader impacts, that often this has to do with your stakeholders, and the broader impact should be something that you think about early on in the process, not as an add-on or at the end of your project, because it's going to look disjointed and not integrated. One thing that I hadn't thought of before was that partners sometimes need to be included in your funding considerations. So when you're planning your budget, you might want to consider the needs of including that partner in your budget and your budget justification as well. One more, please. And from that, I'm going to switch back to Maureen and our panel.
Great. Okay, we can turn this off so we can hear Sathya. But I'm going to keep going. Thank you. Yep. So I would love to introduce our panelists now. Sathya Gopalakrishnan is an associate professor in the Department of Agricultural, Environmental, and Developmental Economics at Ohio State, although currently she is speaking to us from the University of British Columbia, Vancouver, where she's an international visiting research scholar at the Peter Wall Institute for Advanced Studies. Sathya has a great deal of experience with convergent research as a founding member and former director of the STEAM Factory here at Ohio State, as the PI of an NSF informal learning project whose title I will give you because the first word is convergent. Convergent learning from divergent perspectives, interdisciplinary collaborations in informal science communication. And more recently, as a panelist on last year's Growing Convergence Research proposal reviews at NSF. She's also done some other visioning and committee work with NSF that she may choose to tell us about. Elena Irwin is also a professor in the Department of Environmental and Developmental Economics. She serves as the faculty director of the Sustainability Institute here at Ohio State, which was founded earlier this year and whose strategic plan is riddled with the word convergent. Elena is the PI or co-PI of several large NSF interdisciplinary research, education, and engagement awards, including most recently an Infuse project and an NRT entitled, which I'm going to read because the first word is convergent, Convergent Graduate Training and Empowerment for a Sustainable Energy Future. And Rajiv is also a co-PI on that one, and since she's an environmental economist and he's a computer scientist, we've got convergence in action. Elena is also a co-author, nice. Elena is also a co-author of NSF's 2018 report, Sustainable Urban Systems, articulating a long-term convergence research agenda. Finally, Rajiv Ramnath is a professor of practice in the Computer Science and Engineering Department at Ohio State, where he collaborates with industry and other academic units on research, education, and workforce programs like the NRT. But this is the tip of the iceberg on a diverse career that includes academic, industry, and government. He recently returned from a 3+ year rotation as a program director in the Division of Advanced Cyber Infrastructure in the Computer Information Science and Engineering Directorate at NSF, where he oversaw a mere $140 million portfolio in awards. Prior to this, he worked for many years in industry.
None of which was mine, but...
leading government-funded research and commercial product development. So he speaks and thinks in all 3 languages, academic, industry, and government, and maybe like many, many computer languages that I don't know to list.
Thank you.
Yeah. So, Sathya, can we hear you?
Yes.
Awesome. Okay. To you first. Thank you for bearing with us with all the jumping. So we've just heard a little bit about the teams that won last year's GCR competition. Can you give us any insight into what you learned and heard as a panelist, and maybe even if you might have been familiar with any of the projects that Kate profiled? Kind of, what are your thoughts and reflections?
Sure. Thank you for inviting me to this panel. I was trying to give a little bit of a view here. I have literally the best spot on UBC campus right next to the Rose Garden. It's really great. So I don't think I am, I don't think I can discuss specific proposals that we were asked to review. So I'm going to refrain from actually talking about any of the projects that were funded and whether or not I was on the panel reviewing those projects. Instead, what I do want to do is mention two things. I'll start with the big takeaway for me was that there are two, the 2 points that, the 2 points that Kate really emphasized was this, addressing an important problem or addressing a problem that is of societal relevance and is a large problem, so a grand challenge sort of problem, which is, similar to the nanoplastics project, or the two that were highlighted were both examples of projects that were addressing a really societal relevant and a policy relevant problem. So that was one. And the second was this deep integration across disciplines. The impression I got was that proposals or projects don't have to be ones that do everything. So there is an approach which would be fewer disciplines. So it could be microbiology and toxicology or environmental chemistry, but the sort of big reward or the radical idea could essentially transform the disciplines by very deep collaborative integration in the project and in the science. So it's not just addressing a problem which could be, plastics pollution in the marine environment, but it's actually going farther in terms of disciplinary, advancing disciplinary knowledge and what might happen when two disciplines potentially integrate in a very deep manner. So that, I think the expectation is an idea that could potentially be transdisciplinary, even leading to a new discipline. Not expecting that would happen out of one project, but an idea that could move in that direction. And it's hard, I think, to think of a project that involves multiple disciplines and really brings together a number of perspectives on the same problem and achieve this kind of deep integration. So I would say that when, as a panelist, we definitely looked at projects that were addressing broad problems and brought multiple disciplines to bear in a way that engaged broader participation, were community relevant, were actually bringing in stakeholders into the process of research development and research questions development. But there were other projects that were a little more traditional, maybe in the sense of the science, but were integrating disciplines in a much deeper fashion. So I think there is a little bit of a trade-off there that could be acknowledged, and you could go either ways, but being very clear in where the contribution or where the project is going to contribute towards interdisciplinary research, and is it convergence to answer a big problem where a number of pieces are already there, or is it convergence that could even transform a discipline? And the way they talk about it, and I don't know if this came up in the in the report that was written and so on. But what I heard from the program director and even what was discussed at in the panel was thinking about these projects as a research startup. So they often refer to it as a startup in the sense that you're given a smaller amount of seed funding to see whether this collaboration could actually be a rapid trigger to something that could grow bigger. And if you can establish that in the first year, you get additional funding, right? So there is this idea of what is really transformative that you can lay the groundwork for within a short amount of time to make your value proposition that this project will be successful for 3 more years or for 2 more years to get the second round of funding. I think it's 2 and 3. So, so that was, again, just in terms of mindset in thinking about these projects when we're developing proposals, I think having that startup idea of this is something new, there is something transformative, but in order to know whether it will work or not, you probably need some lead time, and that's why they're splitting up the funding this way. So that was the other takeaway that I had. I'll reiterate a point that was already brought up, which is the importance of facilitation and having this, boundary spanning translator in the picture, especially if the project is encompassing a range of diverse disciplines. So that, I think, was discussed a lot in the panel, and projects that clearly showed a plan for how everyone involved in the project would not only have a role to play, but also be able to talk to each other and overcome jargon barriers and disciplinary barriers, and having that formally be spelled out and having a clear structure for how different participants, different PIs would be able to interact and facilitate that. The process of convergence was definitely valued a lot. So proposals that laid out a really clear structure for that, whether it was meeting in person or whether it was having periodic larger groups and some small groups. I think one that was discussed a lot and a model that seemed to resonate quite positively was where you had a structure where there were a number of small meetings, and then there would be where you had disciplines interacting with one another, and then you could see once every few months a larger team coming together to see how the different pieces fit together. The other thing that was bounced around a lot was if you could think of this as lab rotations, right? So you have say students or postdocs from one discipline and one lab actually spending a significant amount of time in another person's lab to understand, to be able to get to the point where you can deeply integrate disciplines. So it's this investment of time in moving beyond just connecting the disciplines to very purposefully integrating where where there could be a fusion which could potentially lead to a transdisciplinary outcome. Those were my big takeaways.
That's great. Thank you. Rajiv, let's turn to you next. Any reactions or perspectives from your NSF world?
Sure. So, so one reason for why the requirement of the big idea, so the compelling problem kind of thing, is because it is really one so that all the participating disciplines can have a scope for their research. If it's a small idea, then it's hard to integrate. That was the thinking. Mm-hmm. And it had to be a long-term kind of research stream, so the bigger the idea, the more sustained research would be needed in order to address this issue. Think gravitational waves. It took 25 years of funding before they could finally show that there was this discovery, right? So that was one thing. I was a program manager on the CRISP program. I'm not revealing anything by saying that, but in all the proposals that came in, one challenging difficulty was to really define the convergent research in the proposal. And while I really appreciate Sathya's point of there were two kinds of proposals, one were, research tightly integrated, and other one more broad-based, multiple disciplines, but the research itself not completely defined, right? I would really recommend that if we are to put together a proposal, that we really think through the convergent research that we're going to do and show how those research themes are integrated with each other. So if there's a big societal problem that requires, that has reached a certain threshold based on the methods that are available, right? If data science could scale by X, it would take this to the next level. So you're able to go from local to global perspectives, for example, right? And then how could we then generate the requirements for the data science team? And then once this was enabled, then how would the research for the, say, the social science team progress? That kind of thinking really has to be done, and it has to be done upfront before the proposal even gets started on. Otherwise, lots of cycles are spent in writing the proposal without that theme having been identified. We saw this a little bit in the sustainability NRT as well, right? So that's one thing. Then I did like you. I looked at a few awards, and they kind of fell into two categories. There was a bunch of workshops and RCNs being proposed. Being awarded. So workshops to do discovery in terms of this convergent theme, and RCNs are research coordination networks. The idea is to bring people who haven't collaborated before, bring them together, right? These are long-term networks set up. And then there were large-scale institutes. So the funding that's made available to this program, is close to 5 million, right? So we should be thinking big. So institute level kinds of things would be good to think about, but we can certainly lead up to it with things like workshops and RCNs and so on. The other thing is one test of whether convergence has truly worked is can we name this convergence research as a discipline? So these are these three disciplines that are collaborating, but if this is the research, can we call that a discipline? Right? That's a good test for whether we've achieved that degree of convergence.
Because if you cannot call it a discipline,
right,
then you likely have
not converged. Right. Exactly. I really like what Sathya said about the whole research startup idea. The other thing is, if we are to put a convergence proposal together, we should really leverage our strengths, our regional strengths that Ohio State has. Lot of and we are uniquely situated to address those. A lot of the broad-based ideas have, in a sense, been taken already in the awards that have been made. So let's really leverage what we have tightly, strongly. The other thing is there's a reason for the two-stage, and the reason for the two-stage is because NSF realizes that this kind of research is difficult, so they want to have that first stage to have folks prove themselves out before they award the next money. So just keep that in mind. And just to throw out an idea for an institute level kind of thing, right? It should have a theme. For example, a mixed methods institute. We could have an institute for mixed methods data science research. I didn't see that in the list. So things like that is what we could talk about.
Great. What does that mean?
Huh?
30 seconds on what that means.
The mixed methods?
Yeah.
So a mix of qualitative and quantitative research, for example. You can use the qualitative research to validate hypotheses for which you don't have the data. You can use the qualitative research up front to identify, define the problem, identify the data sources, come up with initial hypotheses that potentially the quantitative research may then address. Right. And then there's a validation step, which is kind of difficult to do in quantitative research. So you can use the qualitative research at the back end to sort of validate your data-driven insights. That's the kind of thing.
Great. Yeah. Great. Anybody interested, talk to Rajiv after. So Alina, now to you. From the project and team perspective, maybe, how do you see convergence playing out actually on the ground?
Right. So thank you. So as I was sitting here listening, I thought Sathya and Rajiv had really good good views on this. One way that I heard recently convergence be described is, so how do you know if you're asking a convergent research question? The way you know that you're asking a convergent research question is if you take one of the disciplines out and you can no longer answer the question. And so that was kind of an easy way, I thought, to think about, kind of, that's the litmus test for whether it's a convergent research question or not. Another thing that is we've, in my experience of thinking about these kinds of research questions, I think it's really intriguing to think and to challenge yourself to think about what do you know are shortcomings of your own disciplinary perspective or framework. And if you were, so for example, I'm an economist. If I were a non-economist, what would be the things that I would just totally pick apart and laugh? And what, in fact, do non-economists laugh at in the science of economics? And I know what those things are. And so that, to me, is a great opportunity for thinking about whether that could be a convergence research question, right? Because you know in your own discipline what those maybe, heroic assumptions are that you're making, or, or things that you're kind of treating in a more stylized way. And to give a specific example of that, there is a hybrid new discipline that has evolved from the intersections, and initially it was big fights, but now it's more collaborative between economists and ecologists, and it's called ecological economics, and it's an area that has evolved over decades. And it started with ecologists essentially pointing out to economists all the really dumb assumptions that they're making in their models, and then coming up with their version of the models, which economists then laughed at and said, that's ridiculous. You don't understand the first thing about economics. It kind of got stalled out there for a long time. But eventually, I think, some more open-minded people came along and started kind of working on the edges of those different things. And eventually, you do have this new discipline, hybrid kind of discipline that has emerged in ecological economics that really does take parts of economics and parts of ecology and bring them together in new ways that provide novel insights. And that, and it's still evolving, frankly. I mean, there's still, a lot of debate and discussion, but I think that's when you kind of know that you might have something, is if you can identify where these tensions are. And so to Kate's point about working with people who don't have ego and who are open-minded, the only way that you could make progress on a question like that is if you did not have a big ego and if you were open-minded to other points of view. Because there's the past of this particular example is littered with just ferocious fights on both sides of people saying, you are so dumb and I'm not going to engage with you. And that's not a very productive way to go about convergent. You won't get to convergence research if that's the attitude. And this goes on today. Like literally in the last few weeks, we were having a research meeting with our food, energy, water team, and we were talking about how we were modeling economic production functions in our dynamic regional model, and our lovely engineer who models industrial processes eventually just couldn't contain himself anymore and just blurted out, but you're not following the first law of thermodynamics. And to which our regional economist, dynamic modeler person said, huh? And because he wasn't familiar with the whole history of ecological economics, and I just laughed because that was actually a debate 20 years ago in the history of ecological economics. And so these debates continue, and actually we see it as a great opportunity for us to do some convergent research because that's not a fully solved problem at this point. So those are my observations. I could go on, but I'll pause.
That's great. Thank you. That's great. I'd love to check in if there are any questions from our online. Okay, great. So just to follow on quickly with anybody, and Sathya, Rajiv, Alina, what comes first, chicken or egg, in terms of problem, team, or idea? So like big societal stakeholder problem, do you have the team first? Do you have the the idea first and then you go recruit those? I'm sure the answer is all of the above. But just, if you can talk through some examples that you've seen or kind of rules of thumb that you've observed.
So if you want me to start, I've always myself been problem driven. So for me, the problem has always come first. I've had a history in industry where we thought the other way, where we thought solution first, and that didn't quite work out so well. Some people didn't want to eat the hamburger we were feeding them. They turned out to be vegetarians, right? So, so I think the problem has to come first, and somebody deeply immersed in the problem should at least drive the initial step of, look, here are the difficulties I'm having in addressing this, scale, scope, things like that. Who's willing to help me, right? And then bring the. I think the problem has to come first. Yeah.
How about you, Sathya? Any opinions on that?
Yeah, I wouldn't say my experience is as wide, but
I'll jump in for a second.
Yeah.
I don't disagree with what Rajiv said. I would also underscore the importance of the team. For anyone who's done interdisciplinary work, you've probably had the experience where you've had a team member who's maybe not in it for the same reasons you're in it, or for different reasons. Oftentimes interdisciplinary research is, at least in our discipline, you get more funding through the interdisciplinary grants than you would just straight up econ grants. And so it could be, the motive to do it could be more resource based. And I've had the experience where having someone who's motivated by being a resource hog is just a real suck to the whole project, and it really can demoralize people and can really turn things in a wrong direction. So I think having some common vision and some shared values in terms of the research and how you're going about doing the research is super important, because you can have done a great job of identifying the problem, but if you don't have the right team, you're not going to get off the square out of the gate.
So, Rajiv, do you want to tell folks where they can kind of learn more about the science and team science best practices?
I wouldn't know to the extent of URLs and things like this, but NSF actually produced a pretty large, comprehensive report on this and a booklet and so on. And if I dig through all the stuff I brought back from NSF, I might actually find a copy of it, so I can try and find it and provide it. But yeah,
it's all available
online, surely.
Right. There was a report on the science of team science at some point from the national academies. But there's this thing that we have on our desks in the research development office, which is the Team Science Toolkit, which is the much more user-friendly, has pictures version of how you manage this. And a lot of the things that are coming up today are recommendations that get together in a physical space as much as you can. Make your expectations really clear at the beginning. Are you in it for the resources, or are you in it for other reasons? And what are your needs? What are your expectations in terms of sharing credit and resources? How will you manage conflict? Things like this. So those resources, we're evangelists for those resources in our office, because from the side of helping people prepare proposals, we can tell if a team is knowingly or unknowingly adopting some of the best practices of the team science community. Then we know that their proposals are their project development's going to be better, their proposal's going to be better, and ultimately they're going to have greater impact. So there's our pitch for that.
Unless I'm mistaken, there is a requirement for a very specific and intentional management plan that goes with this Convergence Research proposal. You have to articulate how you actually are integrating the disciplines of the study. I believe it's a separate and required section of the proposal, but I'm not 100% certain. So that's where some of this actually thinking through how you're going to manage this on the back end, not just saying the nice words or pulling it out of the toolkit, actually thinking about what that looks like.
That's right. To ineptly summarize what one of our attendees just said, because they can't hear it online. Just a reminder that some of these team science resources, while also being best practices, are the type of thing that you can explicitly and need to explicitly think through and then articulate in the growing convergence research proposal, because those that's part of what they want to be doing in their startup mode. They're saying, okay, we'll give you this money for this great idea, but how are you going to make sure you're integrating these disciplines?
So I know Satya's trying to get, but are we able to get her?
Yep, go ahead.
Okay.
Sathya?
Can you hear me?
Yes.
Yeah.
Oh, okay, great. So I wanted to respond to just a couple things here about, I agree with both Rajiv and Alina that the problem, I would say, does come first, but having a good team is critical to getting that to work. I'll just give one example from my own experience, and this is sort of what I think would be great for a process for convergence research, tying really well with NRTs and so on. So my own PhD process, or my own PhD research, was what I might define today, what we would define today as convergence research, because it was an interdisciplinary coupled human natural systems, or the precursor to a coupled human natural systems biocomplexity grant that funded my research. But part of it was a whole year, literally, of me as an economist spending time learning the code that would operate a geomorphological dynamic system. So understanding what's going on, not that I become a geomorphologist, but spending enough time understanding that world and how the system works. And it's often hard to do that as PIs. Like PIs, faculty don't have as much time to invest in learning a whole new discipline, but graduate students and postdocs are ideally placed in the situation where they can afford to take 6 months to really take a course or two in another discipline and understand what is behind the models that we're working with, or behind the methods that are being used in a different discipline, and then get to the point where you can actually think about something that would evolve into a new discipline, right? And literally, even before all of this was happening, 10 years ago, we were throwing around this thing of, morphodynamic economics as potentially being a field where we were thinking about evolutionary dynamics of natural systems and economic systems together, and whether that could say something new about coastal evolution. This work was in coastal adaptation and climate change. So I think that investment of time and being able to, if we at Ohio State can actually leverage other grants that could go towards professional development of graduate students or postdocs in this process, to prepare the workforce, right? To prepare the team to be able to take on these challenging questions that could lead to transformative research. I think that is critical. So it's hard to essentially just have a ready-made team, or a team that's ready to go, or get the problem and identify exactly what the pieces are. So I think part of it is also just the culture of the institution in just constantly being able to set the stage to have ongoing programs that would prepare teams when opportunities arise, as opposed to saying we are only going after a convergence proposal. To do that well, you need a number of other pieces as well.
That's right. Well, in the interest of time, echoing.
Yep, second.
Okay. In the interest of time, I would love to wrap up now. Sounds like it ended.
Nope, it didn't.
I'd like to wrap up, but Sathya provides me the perfect segue. And actually, the last few comments by all of our panelists, it sounds like what you really need is opportunities for collisions. So with people who own and live with problems, the problems every day that then you might want to solve, longer term collisions of people kind of walking in each other's shoes in a disciplinary sense. And then, of course, the opportunity to connect with people.
Maureen, I do have one question.
Yeah.
Real quick. Mixed methods and combining social and physical sciences are reasonable progress, but what's the potential for including the humanities, which are still academic disciplines, and or the knowledge that exists outside of academic disciplines in this NSF program?
Okay, since anyone who's online will have read that on there, okay, I won't repeat. Did you hear that? Integrating the humanities. Rajiv, what's your quick take on NSF's valuing of the humanities as an integral partner?
So firstly, it would be very welcome. It would be seen as very positive to the proposal to have that, and it would just from a funding perspective, it would receive strong moral support from the SBE directorate if that integration was well done. It's not a directorate that has a lot of money, so they might not provide funding, but they would certainly push to have such a proposal awarded simply because they would see this as essential to them.
But humanities, non-social science humanities.
Right, so including things like storytelling and so on, right?
Yeah.
History, philosophy, English.
Exactly,
Yeah.
exactly.
Yep.
History, certainly, I can see a clear role for, specific, language-oriented departments could potentially sort of serve as a component of the problem, I would think, right? For example, understanding annotations on ruins and artifacts to sort of, something like that. I can see a role for. I'd have to think of it a little bit more to understand how they could broadly apply. But I think that would be certainly unusual in a proposal and could provide us with competitive advantage. Mm-hmm. Yeah.
And I would say that probably the short answer on that is if it makes sense in terms of answering the question, then it would be viewed, and if we're really integrated in that way, it would be viewed as very positive.
I would say the same. Can you hear me?
Yep.
So I would echo that same sentiment, and I can think of examples where naturally biased towards fields that I'm familiar with. But if you think of a big question like climate change or adaptation, or even risk and extreme events, there is a clear and a very natural connection with arts and humanities in terms of even understanding risk, for example. So the project that I'm involved with has a component where you have you have theater involved in putting together a play about extreme events and getting the local community to participate. So there's an element of education, but there's also the element of data and understanding how communities respond to storms and floods, for example, and what is the emotional reaction and how does that affect people's risk perception. So that could be an entire research program and a research study, and understanding those risk perceptions immediately ties into how people will respond and what kind of policy triggers could nudge behavior, right? So if we are thinking about how do we get people to adapt better and what might be the sort of mitigative or preventative action that individual communities can take, this could be a way in which you can actually both communicate the science as well as gather information from the local community or from people who are in that situation. And that's one where I've seen it's worked really well in this particular project in North Carolina that I'm working on. History, as Rajiv said, is also a really important sort of an easy way to think of linkages. And I think ethics is really big, especially when it comes to things like data privacy and so on. So there is a clear connection to what is fair, what is ethically sound when it comes to the data cyber world that we're in. And so, disciplines like philosophy naturally fit into understanding where some of those moral theories and theories of ethics come from, right? So it's not, and again, it's not something where I think one would need to go out of the way to make sure we hit humanities and every discipline has to be involved, but being able to find that connection, I think, is definitely viewed positively, and is often, when it's not a stretch, it actually fits really, it comes together quite well.
Thank you for that. Thank you. So could I have the previous slide, actually? Great. I'd just like to make everyone aware, this is my punchline for we need collision events so we all can get together, and here is an example of one. The second part of this workshop series is only in person, so sorry online people, you'd have to come here. Sathya, you'd have to fly back. But it'll be November 4th at 2 p.m. and it's being facilitated by some colleagues from the Department of Design. Speaking of the arts, humanities, non-science disciplines from which we gain so much. So that will be there. I also learned this morning about another kind of convergence-themed discussion, I guess it will be, which is converging on wicked systems problems as part of the, you say it, the
BANR, which is the Board of Agricultural and Natural Resources, which is part of the National Academy of Sciences, right. Engineering and Medicine.
And Ohio State was selected to host one of the conversations on wicked science, or excuse me, wicked systems problems. I think focusing on the food and land systems in particular. That will be November 18th from 1 to 3 p.m. at the 4-H building, and more details soon on the Sustainability Institute website as well as other places around. I'd like to acknowledge and thank our panelists and Sathya, including Sathya for taking time from the Rose Garden in Vancouver. To thank my colleague Kate Hazozello and Kathy Jackson from the Sustainability Institute for planning everything. And also Doug Dangler for trying to wrangle the technology over there. Could you flip to the next one? That's what I was saying before. If you do already have an idea, we at the Research Development Office may be able to provide you with some guidance, tools, and support. So feel free to get in touch. Thank you to our people. So feel free to get in touch, which is the next slide, which has our dot numbers. And we'd like to thank everyone who braved the construction site. Not sure if online you can hear how much construction has been happening in the last hour. Thanks to everyone, and we'll close out here. Thanks.
Thank you. Thank you, Maureen.
Yeah.
Thank you.